Hello. We will work with calculation of pH scale. And the calculation of pH scale, of course, is 0 through 14. Anything more than 7 is basic. Anything less than 7 is acidic. Today, we're calculating the pH scale based on the concentration of ions given to me. Okay. And I work it in the hydrogen ions. Very simple. This represents the given number. The N represents the given number. This is given to me. Therefore, concentration of the number given to me equals negative log of the calculator and plug in the number. Let's do an example. Let's do a few examples, by the way. Calculate the pH scale of a given number of hydrogen ions, 1.0 times 10 to the negative 9. If I plug this in the calculator, I'm going to end up with 9. So the pH scale of the substance is 9. Another example. Calculate the pH scale of a given number of hydrogen ions, which is the way that I want to work it in, of 2.7 times 10 to the negative fifth molarity. I do the inverse log in the, I'm sorry, the negative log in the calculator, and my response would be 4.57. Okay. On the first one over here, I had a 1, which means that my pH scale is just this number. On the second example, I had 2.57. I need to plug in the 2.57 times 10 to the negative fifth on the calculator, of course, negative log, and I end up with this 1. Therefore, when I have a 1, it is just easy to say that the pH scale is the number or the power of the number. However, not when I have any other number besides 1. Let's repeat this. To find the pH scale, I need to plug in negative log and the value of the number given to me. What if I am given OH concentration and not the H concentration? Okay, I need to find the concentration of hydrogen ions in order to work it out. How do I do that? Let's recall that the concentration of the scale is hydroxide ions times hydrogen ions to give me 1 times 10 to the negative 14. If I go back a minute over here, we recall this. This times this gives me that. Therefore, I am given here, sorry, the concentration of hydroxide ions. Therefore, I divide my constant, which is 1.0 times 10 to the negative 14, over what's given to me. In this case, I am given 1.0 times 10 to the negative 6. My concentration of hydrogen ions would be 1.0 times 10 to the negative 8. Now that I have my H plus concentration, I do the inverse log of the number, and my concentration is on the pH scale, sorry, would be 8, a basic solution. Another example. Calculate the pH scale of a given number of hydroxide ions, 4.0 times 10 to the negative fifth molarity. Okay, I have to work it out in hydrogen ions. Therefore, 1.0 times 10 to the negative 14, this doesn't change. I divide that by 5 times 10 to the negative fifth, and I end up with an H concentration of 2.0 times 10 to the negative 10. Now that I have my hydrogen concentration, I will plug that in on the calculator, negative log of 2.0 times 10 to the negative fifth. This equals sign, don't let us fool you, shouldn't be there. Okay, so negative log 2.0 times 10 to the negative 10, and I should get an answer of 9.7. So the pH scale of this substance, of this OH substance that was given to me, is 9.7. And this is calculation of pH scale based on the concentration of hydrogen ions. I hope this helps you out.